So if you are an expert at finding the GCF of things, then that makes this very easy, but there is a new step that we need to learn today as well. And there's two different ways of thinking about it. So over the course of the period, I guess, you want to realize that there's two ways and figure out which way works best for you. Okay, we'll talk about both ways, and you have to make one of them work. It says right here, step one is to find the GCF between all the terms. These are all binomials. They have two terms each, so between both terms. So imagine for a moment, don't write this down, just like we were working yesterday, imagine it said find the GCF of 3x and 9. Okay, what would it be? 3. So what I'm going to do is I'm going to go equals 3, and she's right. So that's good. If you weren't right, that's okay. We'll talk about that, what happens if you make a mistake or something. We'll talk about that after. But you write the GCF, then you put a bracket. Now here's the new part. So hopefully that's what we already learned. So half of the question is already done. But here's the new part. I have to figure out what's left that goes in the bracket. And so what common factoring is doing is undoing, it's the reverse of the distributive property. Okay, so in order to make a little bit more sense of that, I'm going to go take a bit of space and show you what I mean by that. 2 bracket x plus 3. How would I distribute that? Who can tell me what that is supposed to be? Taylor? 2x plus 6. So you got 2 times x and 2 times 3 is 2x plus 6. So factoring is going the other direction. Is you're given this step and you're going backwards. So the GCF is what I put out here. And I have to figure out what goes in the bracket to make it turn back into that. Does that make sense? Do you think you can do that? That's kind of one, like I said, there was two methods. That's kind of one of them. Just think, well, what would I put in the bracket to make this work out? So for this example, what would you put? Taylor? Does anybody else think that's right? Do the distributive property in your head. 3 times x is 3x. 3 times negative 3 is negative 9. Right. Now, how did she get that? Here's the other method. I mean, they're essentially the same idea. But here's the other method, is I take the GCF and I do that division that we did a few weeks ago. And I go, what is 3x divided by 3? It's x. What's negative 9 divided by 3? It's negative 3. So you are actually dividing it out. And if it's a little bit trickier or a little bit bigger numbers and you can't just kind of visualize it in your head, then you might have to do the division. So the second step, figuring out what is in the brackets, is taking your original expression and dividing each term by the GCF and put it in the brackets. Few things to think about, and this is why we'll practice to catch all these little tricks. If the original expression has 2 terms, in the brackets has to be 2 terms at the end. It can't have 3 terms and then all of a sudden have 2 terms, or 2 terms and then 1 term. It can't go down in number of terms. Does that make sense? So if I start with 4 terms, in the brackets in the end will be 4 terms. There's a couple of situations where people ask questions and go, oh, I think one of them disappeared. No, that's not possible. You can't divide by something and get 0. So they can't disappear. Okay, let's try another one. So what's the first step? Think of this as 2 steps in your head. My first step is find the GCF. In this case, between 4x squared and 6x. Mackenzie, do you know what it is? Nice. 2x. Bracket. So it's like, how do you do it and how do you write the answer are two different things. Because the tricky part is with factoring, and there's all different levels, all different kinds of factoring, but it's always the same, as you need to know how to write the answer. The answer doesn't automatically work itself out when you go through the steps. You need to know what the answer is supposed to look like. That does make it tricky. So what's left that I put in the brackets? Adam? 2x plus 3. So now let's check. And folks, listen carefully. You are never going to do this, which equals 4x. Never put the answer below, because then that's your new answer and that's wrong. So there's different things you can do. You could put a line and write like check and then do it. Or you could do it on a separate piece of paper. Or you could do it in your head. So 2x times 2x is 4x squared. And 2x times 3 is 6x. That's right. So I'm done. But I'm not going to write anything else. That has to be your last line. Yeah. Yeah. Absolutely. Okay, next one. I want you to try this one on your own. Your first step is to write the GCF. Find the GCF, write it, and then with a bracket. And then try to see if you can figure out what's left. Okay, let's see how we did. Tamara, can you give me just the GCF? 5x. How many people got 5x? Awesome. Who's got something left? Summer, do you have what's left? X squared plus 2. How did you get that? This is a hard question, but can you explain how you got that? Awesome. So Summer's thinking is that idea of like, what do I put in the brackets to make it work back to the kids? Awesome. I love that. Really good thinking, right? Thinking like, what would I have to multiply by 5x to give me 5x? I mean, that is dividing. 12 divided by 3 is like asking, what do I multiply 3 by to get 12, right? It's the same thing. Like people think about this stuff in all kinds of different ways. Awesome. Okay, if you're not done D, I'm going to give you a few seconds to finish D. I know most of you already started it. Who can tell me the GCF part? Brianna? 4a. Awesome. And who can tell me what's left that goes in the brackets? Somebody else? Noah, did you get it? Not yet. Did you get part of it? Taylor? 4a plus 1. So this is the kind, folks, watch carefully, that some people think when you divide 4a by 4a, it disappears and it's gone. And they would have just said 4a. But that wouldn't work. So plus 1 is right, very good. That's a common error that when you get that idea, people don't know what to write, so they put nothing. But it's 1. And again, think about it. This will always work. 4a times 4a. 4 times 4 is 16. A times a is a squared. 4a times 1 is 4a. Right? So it works. It works every time. That's common factoring. There's a few different types. What if you have 3 terms? What if you have different kinds of variables, that kind of stuff? So we're going to practice a little bit. There's 2 different ways that you can practice. And I would recommend doing a little bit of both. There's just like a worksheet that's got a bunch of different examples. You know, the first couple of sections are pretty simple, and then it starts to get a little bit more complicated. And actually, there's a whole bunch of worksheets, but it's kind of overwhelming. You don't have to do them all. But if you could try like a couple from every question. And then when we get to some of the later worksheets, let's see, we do get to some slightly harder ones, trinomials and that kind of thing. But then there's also, you'll have to go into the classroom, but there's a website. And I would recommend you could do a little bit of both. But if you want to start with the website, you could do that. And it puts like 12 questions on the screen. You have to answer them all at the same time and click check. And it tells you which ones are right and which ones are wrong. The only thing is it's very picky. If you forget to put it in a bracket, it's going to tell you what's wrong. If you even write the terms in a different order, it's going to tell you what's wrong, even though it's not wrong. So you have to write it exactly the right way. But it's a neat little website, so I would try it. It's linked in the classroom. And if you want, you could even kind of do it with a partner. And what I would recommend is do all 12, hit check, and then see if you can fix the ones that are wrong and make them right until you can get all 12 correct. Like that's what you could use a partner for. You could both do it individually and see and kind of check how you did. I got 9, I got 8, and then see if you can fix them all kind of together or something. Okay?